Okay, this is section 02. Let's see. We're on 02. Whoops. We're on 02. Flight instruments. Is this part 3? Well, the first day it was like 1 minute, right? Right. All right. So it's either part 2 or 3. All right. So let's talk about reading an altimeter. Let's talk about reading an altimeter. There are up to 3 needles on an altimeter. First, so this one right here is pointing to every 10,000 feet. You'll notice it's right on the 1. So what's 1 times 10,000 equals 10,000 feet. So that tells me that I'm pretty close to 10,000 feet. Now, if the needle was pointing right here, 0, 2, 4, 6, 8, if this triangle was right here, that would tell me that I'm pretty close to 8,000 feet. But that's just an estimate. Then this needle right here is telling me how many thousands. So you notice in this case it's pointing to 0. So this triangle is pointing to 10,000. This is pointing to 0. And then this one is pointing to 180. So right now this altimeter is indicating 10,180 so that's indicated altitude, because no matter what it shows, whatever it shows, that's indicated altitude. But if we had set the Colesman window to the correct altimeter setting, what would this 10,180 also be? It would be indicated, and if this was set correctly to the correct barometric pressure, then what would this altimeter be telling us? And we use that all day, every day as a pilot. Run. No, try again. MSL. It's altitude above mean sea level. How often are we as a pilot going to make sure that the altimeter setting in here is correct? All the time. And as we're flying along on our cross country, how often do we have to set it? Well, you generally set it about halfway between altimeter barometric stations. But how close does that station have to be by regulation? How close does it have to be to where you are? No matter what, you can never be more than 100 nautical miles away from the place that has the altimeter setting. So if we fly south of here about 20 miles, we'll be less than 100 miles from Bakersfield. We could set it to the altimeter setting, gotten off of the radio for Bakersfield Airport. We'd be legal all the way till we got to 100. But as soon as we exceed 100, we needed to have changed it. Question? Yes. I have my own plane, right? I have flown from an airport outside of Sacramento, Davis Airport, to Kingman, Arizona. I had a little bit of a tailwind. It was about 420, 440 miles. And I landed with just over 30 minutes of fuel. That's I've flown on, you mean on one trip without landing? In a light airplane? Yeah, that's the longest I've ever flown. The longest time I've ever been on an airplane without landing, I think it was a 14-hour trip from Guam to North Dakota. But that was in an Air Force jet. I think we got air refueling over Hawaii. It's been a long time. Say that again? It's easy to fly over sea level. You don't have to change it, is the question. The answer is, if you're flying any airplane, you have to keep setting that, and you're below 18,000 feet. You have to keep setting the altimeter to some place that's within 100 miles of wherever you are. And so you usually pick something ahead of you. So you can fly, you can set it at 99 miles till you get to Bakersfield. I can hit Bakersfield and I actually can fly 99, another 100 miles past Bakersfield, and I'm still legal. Okay, but everybody above 18,000 feet, instead of setting that altimeter to close enough to them, everybody sets their altimeter to standard day barometric pressure. They set it to 2992. Because most people, most airplanes above 18,000 feet are going 200, 300, 400, 500, 600 miles an hour, and you don't want to have to set your altimeter every 5 or 10 minutes. So if everybody sets it to 2992, then you know that if you're at 29,000 feet and they're at 30,000 feet, you're actually going to have that 1,000 feet of difference. Am I answering your question okay? Another question. No, if you get an FAA pilot, the question is, what's the limit to your pilot certificate? How far away can you fly? There's no limit, except for maybe North Korea. You can fly, you can use your United States pilot certificate to fly into any other country. Now, there's some countries, well, now you can legally fly into Cuba. Technically, before, the United States wasn't happy when you came back from Cuba. But I know some people that actually flew to Mexico and then flew from Mexico to Cuba and Cuba back to Mexico. And, technically, yeah, but now it's a lot different now. The last president, who's not in office now, opened up a lot of those restrictions. But the vast majority of countries, that is 99.5% of the countries out there, accept all the other countries' pilot certificates. Now, when you land, they'll want to look at it, probably, but there you go. Now, there are some countries where they're not used to private pilots, they're only used to jets. So I've read about some countries like Saudi Arabia, where you'd be happier if when you got out of the airplane, if you had what looked like an airline pilot uniform with epaulets on. And I don't know if it was Saudi Arabia or not, but it just makes you look like you're supposed to. So, but you can have a pilot certificate from any other country and fly into and fly around in the United States. So there's not really much of a limit. All the countries say, well, if you got a pilot certificate in that country, it's good enough over here, but you've got to let our pilots fly through your country and say it's good enough over there. It's really ICAO. ICAO is the International Civil Aviation Organization, and the ICAO started after World War II, and everybody got together, especially the countries that won the war. Remember the English-speaking countries? I mean, there was France, but they weren't really. In any case, who was flying the most airplanes the day after the war was over? Great Britain and the United States, because France had been actually just liberated, right? So France didn't really have a lot of airplanes, and the Germans are on the losing side, the Japanese are on the losing side, the Italians are on the losing side, so, and the Soviet Union was devastated by tens of millions of deaths. I mean, we're going to talk about it, but Soviet Union had more than 20 million people in the Soviet Union died during World War II. Yeah, we'll talk about it later, but it was not a good time to be a Russia. Well, back then it was the Soviet Union. In any case, who was left? It was Great Britain and the United States. So who wrote the rules? The English-speaking countries that had lots and lots of airplanes. So that's how the International Civil Aviation Organization got started, and guess what? It pretty much wrote out the rules the way the United States and Great Britain thought they ought to be, and everybody else said, well, I got 3 airplanes, and you all got 10,000 of them. I guess I'm going to conform to what you're doing. Okay, great. That means I can fly my 3 airplanes into Great Britain and into the United States and into all the other countries? Okay, fine. I'll make sure all my pilots can speak English, and we'll fly all those rules. So it slowly changed over the decades, but a lot of things are left over. Yeah. If you fly into another country, you either have to be able to speak on the radio the native language in that country or speak English. So English is the international language of aviation. If you fly an airplane into Mexico and you start talking to the Mexican air traffic controller on the radio and you speak in Spanish, they'll speak back to you in Spanish. But if you speak to them in English, they'll speak back to you in English. If you speak to them in French, they will probably query you in English. Because I'll bet you money there's not a lot of air traffic controllers in Mexico that speak French. Because they have to speak English. And since they're in Mexico, I bet you they speak Spanish. Does that make sense? So here in the United States, If English is the primary language that you grew up learning, then you got it easy because all the air traffic controllers speak English and they don't have to learn another language because the international language is already English. You fly to Korea, South Korea, don't fly to North Korea. But if you fly to South Korea and you call them up, you're coming in off the Pacific Ocean, and you call up somebody in South Korea and you start speaking in Korean, they'll talk back to you in Korean. But if you talk to them in English, they'll talk to you in English. So let's go to the next altimeter. I got another altimeter here. So here's another altimeter. You'll notice, look, here's the triangle. 2, 4, 6, 8. So that's telling me I'm at 8,000 feet. And this medium sized is telling me that it's 780-ish, but it's almost to 800 feet. So this needle right here is telling me this is off just a little tiny bit. So this is 920, 40, 60, 70, 970. So this airplane's at 8,970 feet. And if we have the correct altimeter setting in here, this 8970 is in MSL, mean sea level. So you're going to fly around all day, every day, with one of two altimeter settings. Either you're going to have this set for the correct barometric pressure, and it'll be MSL, or if you're above, technically, it's if you're at 18,000 feet or above, you set in 2992, and you're flying a pressure altitude. But everybody else is flying the same pressure altitude. You just might not, it won't be your true altitude above sea level anymore. Yeah, if you're a jet airplane, we're not going to get into it much in this class. If you're a jet airplane, your fuel economy is way, way, way better, or above 30,000 feet. There's less air, so there's less drag, so you can go faster for the same amount of fuel you burn. So that's why jets don't fly along at 5 or 10 or 20,000 feet. They go up past 30. 35,000 is a pretty sweet number. It varies on which jet it is and how heavy you are. As you burn off a lot of fuel, let's say you take off from Los Angeles, you're flying to Hawaii. You may take off and your best altitude may be 32,000 feet. It's 5 hours to get to Hawaii, and you're going to burn a lot of fuel. By the time you get to Hawaii, you'll have done step climbs, and you're probably at 35, 36, 37, 38,000 feet by the time you get there. Because every time you notice in your chart that you have a better fuel burn 1,000 foot higher, you call up the air traffic controller and tell them that you want another 1,000 feet, and if nobody's up there, they'll give it to you. But everybody going in that direction is doing the same thing anyway. So everybody knows that's what you're going to ask for. And then at the last minute, you pull the throttles to idle, and you go, woohoo, and then descend. I mean, in the cockpit, you say woohoo. Don't say that. The passengers don't like it when the pilots are saying woohoo. I mean, I don't think they are. All right, so let's see if we can figure this one out. Here's our triangle. That's 10,000 feet, 11,000, 12,000 is right there. It looks like it's a hair past 12, so we know we're going to be at 12,000 feet and something. You notice here, this needle here is between 400 and 500, so I know I'm going to have a 4 right here. And then, oops, sorry, wrong column. This right here is 20,000. So this is 12, and this line right there is 14,000. So I'm going to be at least 14,000, and sure enough, here's the 4, there's the 5. I'm going to be between 14,000 and 15,000. And this needle is how many hundreds? So 1, 2, 3, 4, 5, 6. It's hard to see. There's about 620. We'll say that's about 630. It's harder to do this. Whoops. In the airplane, it's not very confusing because you climb. And you go, yeah, okay, cool, there's 8,000, 9,000, 10,000, 12,000, 10,000. So it's just looking at it, it's a little bit more difficult to try to figure it out. Again, you notice, look at this case. The altimeter is not set to 2992. You'll set it's at 30. This line right here is at 30.10, but it's really at the next line. So that's actually at 30.12. Again, I'm not going to try to worry about trying to figure this out, because when you're in the airplane, you're going to actually spin this knob right here, and this number is going to go up or down. And you'll notice, just for fun, that it says inches of mercury, IN period HG, inches of mercury. Okay, so we played with reading an altimeter. All right, so next we're going to go into the principle of operation. Effectively, I'll show you here in a picture in a second, is there's some wafers. And when I say wafer, this wafer is really just a sealed container. It's made out of brass or bronze, and it's sealed, and they put 29.92 inches of mercury in it. And then whenever you change the pressure that's on that, it's actually, maybe a bellows is a better way to describe it instead of a wafer. Maybe if I show you a picture. The Colesman window, that's that window with the inches of mercury that you're setting. There's two L's in Colesman. It's not Coleman like the camping stove company. That's Coleman, C-O-L-E-M-A-N. You don't have to spell that for the test. Colesman window. I'll have to look it up. I'm guessing it was named after some human. Whoops. All right. So the altimeter works off of one pressure, and that's static, off of the side of the airplane. So the only pressure it uses is just one. It's the static pressure, and that's the outside air pressure. So if it was a standard day and the pressure at sea level was 29.92, and you cranked in 29.92 in the Colesman window with this knob right here, and you cranked in 29.92, and the outside air pressure at sea level was 29.92, then this altimeter would read 0. So we'll get back to that here shortly. So the air comes in here, but inside these wafers right in here, these are all sealed. There's no holes in them. If the pressure in here gets less, then these are going to try to expand, and it's going to push down. This shaft here is going to rotate. This will move over. It'll spin these gears, spin those gears, spin those gears, and spin all these things. So I'm never going to ask you to draw this picture. What I am going to ask you to tell me is that inside of the altimeter, oh, okay, Brian's, he's thinking he wants to be able to draw that picture. Okay, bring in colored pencils or crayons. You got to do this in crayon on the test. With all the same colors here. Okay, I guess I could let you use felt markers. The air inside of these wafers, inside of these discs, inside of these bellows, it's sealed in there. So if you let air into the altimeter, so you got to understand the case, this round cylinder, it's usually painted black, that is this altimeter. Air can't get in or get out of it except to that little tiny hole on the back that goes to the static port. It's not the air pressure inside of the airplane. It's the air pressure inside of the static port from the outside of the airplane. Okay, so whenever that pressure changes, those bellows, those wafers, they're either going to try to expand or they're going to try to contract. And every time they get bigger or get smaller, they're going to make the altimeter needles move. And it's ridiculously sensitive. It's extremely sensitive. I mean, we were just looking on there, and there's a line every 20 feet. They've been making these things for close to 100 years, well, actually 100 years now. And they've been making really, really good ones for about 75 years. So somebody somewhere knows how to make these things. So as far as operation is concerned, static pressure goes in, and it either gets more or less, the bellows expand or contract, and the needle moves. You as the pilot are either going to set in a local altimeter setting that you're within 100 miles of and keep something set in there that's within 100 miles, or you're going to climb up to 18,000 feet or higher, and then you're just going to set in 2992. If you're below 18,000 feet and you have the correct altimeter setting in there, the altimeter is going to tell you what kind of altitude? It's going to give you altitude above mean sea level, which is also your indicated in this case. Yay. And if you were flying over the ocean, what would be your AGL? What would be your altitude above ground level if you're over the ocean? You take off out of Los Angeles International and you level off at 5,000 feet MSL. You have the correct altimeter setting. So if you have the correct altimeter setting, you're reading MSL. Whatever you see on the gauge is indicated, so it says 5,000. How many feet are you above the ground level? I know it seems like a trick question because you're not over the ground, you're over the water. But the same definition applies. How high are you above the thing that would hurt if you hit it? How much? You're 5,000 feet MSL, you're 5,000 feet indicated. In this case, over the ocean, you'd be at 5,000 feet AGL. Just so you know, the Los Angeles International Airport elevation is 11 feet above sea level. So if you flew over the airport at 5,000 feet MSL, you'd be at 4,989 feet AGL. All right. You probably don't remember from the videos the other day, but there's two factors that are going to make you wish to remember this saying, from high to low, look out below. One is temperature and one is pressure. But I'd write pressure first because pressure is the one that's going to get you most of the time. If you got to understand that although 2992 is a standard day pressure at sea level, most days are not standard. Even though the standard temperature rate is 2 degrees Celsius for every 1,000 feet you go up, that's just on a standard day. That's probably not today. Same thing with a standard pressure lapse rate. 1,000 feet gives you 1 inch of mercury less pressure up to about 15,000 feet. That's on a standard day. Every day is a little bit different. So that's why you got to keep setting your altimeter setting. So let's say I'm flying from Sacramento to Bakersfield, and there is a low pressure area over Bakersfield. So I know you can close your eyes and think about the last time you saw a TV weather forecast, and sometimes they have L's and sometimes they have H's. So this would be a good time to start watching the local news and start watching the weather. It'll help make things sink in when we get to weather. Low pressure area, that big giant L that they put on the screen, means that the pressure is lower than 29.92. Really what it means is it's lower than somewhere else, but for today, we'll just say it's less than 2992. So let's say there's a low pressure area over Bakersfield, and there's a high pressure area over Sacramento. So we set our altimeter setting in Sacramento, and we fly towards Bakersfield. The air pressure gets lower, and let's say you don't reset your altimeter setting, and let's say it's 200 miles from Sacramento to Bakersfield, and you don't reset your altimeter setting, and you're flying from a high pressure to a low pressure. We use this saying here, from high to low, look out below. Let's say you take off and you climb to 3,000 feet and you level off and you keep the altimeter saying 3,000 feet. As you fly towards Bakersfield, you're flying into low pressure air. Even though the altimeter reaches 3,000 feet, you are going to be descending very, 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 very slowly, and you might be all the way down to 2,600 feet by the time you get to Bakersfield. Because that 400 feet is only 0.4 inches of mercury. If it was a whole inch lower, you'd be 1,000 feet lower. What if you were flying at night? Okay, I'm coming up to the airport. I'm going to descend down to traffic pattern altitude, and you think you're descending down to 1,000 feet. Descending down to 0 feet AGL. You won't be happy. It's the same for temperature. Now you'll notice on the air altimeter, there's no knob there with a window to set in non-standard temperatures. That's because most of the time the temperature difference isn't that big of a deal. And if you fly to where it's hotter, it actually makes you be a little higher than you think. It's when you're flying from high temperature to low temperature. Again, we could use the same thing, from high to low temperature, look out below. So if it's really hot in Sacramento and really, really cold in Bakersfield, and you do not reset your temperature, even if you do reset your Colesman window, you'll be a little bit lower when you get to Bakersfield. But it's generally not a big deal until you start getting into the negative Fahrenheit numbers, like -5 Fahrenheit. You don't have to worry. If you're flying in the winter in North Dakota, you need to worry about it, because now your altimeter might be off 1 or 2 or 300 feet. Did I lose anybody there? So that's why you need to keep resetting your altimeter, is because if you fly somewhere, you may end up being lower than you think you are. And I'm not going to go through those pictures. All right, next gauge we're going to talk about is the vertical speed indicator, or sometimes abbreviated VSI, vertical speed indicator. Here's a picture of a typical vertical speed indicator. It's one of those 6 instruments, and so far all we're talking about are these 6 instruments. On the 6-pack, yeah. So you notice right now, it doesn't say anywhere on here, there it does. It says 100 feet per minute is that line right there. So this is really 500 feet per minute, and this is really 1,000 feet per minute, and this is really 1,500 feet per minute. So right here, this needle pointing at 0, that's what it ought to read on the ground. So that's what you're going to do on the ground to check it. You're going to make sure it reads really close to 0. You'll notice there what looks like is a little screw down here with a little line in it. That's actually one of the few things that you as a pilot could operate. You could stick your fingernail in there and turn it if you needed to get this needle to go to 0, but usually it gets caught on the last inspection, and the mechanic will rotate that screw and get that to 0. If it's off a little tiny bit, you don't have to turn the screw. You just say, it's reading 30 feet in a descending, even though I'm not. So you would have to make that 30 feet per minute correction. But 30 feet's typically not enough to worry about. So here's another vertical speed indicator. It says, it's hard to see, but it says 1,000. So this is really 1,000. This is really 2,000. This is 3,000. So this is, and here's 4,000. So this is on an airplane that can climb and descend faster than a little podunk little airplane that goes 100 miles an hour. But you'll notice if this is 1,000, then this needle right here, that's going to be at 500 feet per minute. So I want to get into that feet per minute here for a second. That means over the course of 1 minute or the course of 60 seconds, the airplane, if it stays climbing the same amount, if that needle sits there at 500 feet and it does it for a minute, after 1 minute, you'll be 500 feet than you were. So if you take a little tiny airplane like a Piper Tomahawk, if you were going to go flying at Reedley College next semester, or you take that 152 out there, and they're flying along, and you pull the throttle to idle, and you'll pull out the carburetor heat so the carburetor can't get icing while the engine's at low speed, and you practicing engine outs. You know, I've talked in here before about the engine quitting. I've got 1,000 hours flying little airplanes, the engines never quit, but I've probably practiced engine out procedures 300-400 times. Because that's one of the things that if it happens, you're going to wish you had been practicing it. So, you're flying along and you're with your instructor and it says, okay, we're at 1,000 feet above ground level. So if you're near the Reedley Airport is 380 feet. How high would what would your altimeter say if you were 1,000 feet above ground level? Would it say 1,000? What does your altimeter read if you got the altimeter set correctly? I know it's tough because it's been like 10 minutes since we went over this. It's going to read MSL. So in order for you to figure out how far you are above the ground, you're going to have to actually look at your chart and say, aha, the airport's at 380 feet. If I want to be 1,000 feet above it, I got to add 1,000 to that. I got to be at 1,380 MSL to be 1,000 above the airport. Did you have a question? Can you do what? You could turn on the radio. The automatic weather at airport doesn't say with the airport elevation. That's going to be on a chart. You're going to have to find that yourself, which is real easy to find. In fact, it's on a typical aeronautical chart. It has the airport elevation on it. So it's also in the book. Yes. It's going to be one of the first thing it says. You know what? I'll bring in an example and show you. So, but you're going to, at the moment, you're kind of trying to think about it and go, what the heck does all that mean? This is something you're going to do every single day, every single time you go flying. So you're 1,000 feet above the ground. If your airplane descends at 500 feet per minute, you're going to put the nose up or down to get the airplane at its best glide speed, so it'll descend the slowest amount or go the farthest distance. In a little tiny airplane, that's usually around 500 feet per minute descent. Nice thing, you're going 100 miles an hour. That airplane probably has a best glide at, say, 70 miles an hour. So you're just going to hold the nose up and let the airplane slow down. So you're going to stay at that 1,000 feet AGL for 10 or 15, maybe 20 seconds till the airspeed slows down. And now you're going to let the nose down and keep going at best glide, which is probably around 70 miles an hour. So you actually probably have 2 minutes plus that 20 seconds. But that's, okay. If you're flying that same airplane and you take off from the airport, you're probably going to see on a normal day, on a standard day near sea level, a little 2-seat trainer airplane will climb at about 500 feet per minute. So that's another nice thing. You'll get used to it going, okay, I'm taking off. I've got a 500 foot per minute climb. Yay, the airplane's acting like I wanted. But if I went to South Lake Tahoe, I think South Lake Tahoe is at 5,000 or 6,000 feet. It's not going to climb at 500 feet per minute because the air is less dense and the engine won't produce as much horsepower. You mean like a jet? Okay, if you get in let's just say it's one of the 50-seaters, the question is, how fast do commercial airliners climb? Between 2 and 10,000 feet per minute. If you got in a Canadair regional jet or an Embraer regional jet, an ERJ, flying out of Fresno, the 50-seaters that fly out of Fresno, they're probably going to climb at between 3,000 to 6,000 feet per minute. And if an engine quits, you're still going to be climbing pretty good. I actually asked a student of mine whose parent flew a Boeing 777, which is a very large, it's the biggest twin-engine airplane flying out there is a Boeing 777. What does it weigh, like 500,000 pounds? It weighs like 500,000 pounds. I asked him if you loaded it up completely and took off on a standard day at Los Angeles International at sea level, 11 feet above it, and you took off and put the flaps up and put the landing gear up, and immediately one engine quit, how fast would it continue to climb? He said it'll still climb at 1,000 feet per minute with half of the engines inoperative. I'm not even used to flying an airplane that'll fly 1,000 feet per minute if all the engines are working. All right, so I know the picture quality here is bad, but I wanted to show you a vertical speed negative. So this one is at showing 400 feet per minute descent. 400 feet per minute descent. Descent on this gauge is a negative number. They just don't put the negative signs there. And so here is a nice high-powered airplane. You notice it goes up to 6,000 feet per minute. And right now, it's doing about 3,300 feet per minute climb. So this is going to be a big turboprop or a small jet. And it would be able to maintain that pretty easy. So if you're climbing 3,300 feet per minute, and let's just say you could maintain it, how many minutes will it take you to get to 33,000 feet? I know it's tough. Get out your calculator if you need to. You're climbing at 3,300 feet per minute. How many minutes will it take to get to 33,000 feet? Well, I come up with 10 minutes. So you're cooking. Woo-hoo-hoo. I've flown a little 4-seater with a 150 horsepower engine, and it's taken me 20 minutes to get to 10,000 feet. Mm-hmm. Well, hey, 500 feet per minute, it's going to take me 2 minutes for every 1,000. 2 minutes for every 1,000 to get to 10,000 feet is 20 minutes. But the airplane I'm used to flying around in, the higher you go, the less horsepower there is. So the higher you climb, it doesn't stay at 500 feet. It goes down to 400, then 300. I've been in a climb at 200 feet per minute. It's like, okay, it's going to be 5 minutes just to get to another 1,000 feet. But if the wind is blowing in your direction at a higher altitude, it's probably worth climbing to get there. All right. So, metered orifice. A metered orifice means that there is a hole. And that's what orifice means. Has anybody ever heard of that word, orifice? Okay, some of you have heard of the word orifice, and some of you have not. Metered means that it is a particular size. It was measured. So it's not just a random size hole, it's a particular size hole. And what that's going to do is it's going to give the vertical speed indicator a calibrated leak. And I'm going to show you the insides and tell you what I mean here in a second. Oh, you can go ahead and write that in there. The static pressure from the static system goes directly to the inside of a diaphragm. See how many more words I have there before we get the picture. You know what? All right, I'm going to let you write down measures rate of change. Then I'm going to show you a picture. I don't care how many words are after that. Because really that's what the vertical speed is doing, is telling you the rate of change. How fast are you changing altitudes? Are you changing it at 300 feet per minute? Are you changing it at 3,000 feet per minute? Yay, finally, the picture. All right. So this doesn't do a very good job of showing it. But static pressure goes into this diaphragm, and this diaphragm, you notice with this arrow, can expand and contract. But there's also this little tiny hole right there, and that's the metered orifice. So if you climb up in altitude, so let's just say for fun, you're going up, this static pressure over here is going to get less. Remember, as you go up in altitude, there's less pressure. But at the same time, so if the pressure gets less, and the pressure on the inside of this case stayed the same, but the pressure inside of here got less, what would happen to this diaphragm? Would it contract or would it expand? Pardon me? It would contract, that is correct. So that would push in here and it would push in there and it would make all this mechanism work, and the needle would show a climb. However, you'll notice that there's a little tiny hole right here, that metered orifice, and air can get out. If you didn't let that air out, you'd climb a little bit and then level off, but the needle would stay stuck at 300 feet per minute. So once you've climbed, you have to let the pressure equalize and let the needle come back to zero. So if you descend, this will all go backwards. Again, once you stop descending, well, let's go back to the climbing. Let's say you climb from 0 feet to 500 feet and you level off at 500 feet. There's still a pressure difference compared to where you used to be, but now what you really need is for the needle to go back to zero because you leveled off. You're not climbing and you're not descending. So after you level off, air is going to leak out this metered orifice, and the bellows will expand back to they were, and the needle will point to zero again. And now it's ready to show you the next climb or the next descent. The problem is with this system is that it lags a few seconds. So you're going to write that down. Vertical speed indicator, the indication lags or is several seconds late of what's really going on. It lags, or you could say it shows what happened 3 or 4 seconds ago. It's late. What it's showing is what's already occurred. So let's say you climb and you level off at 500 feet. That needle doesn't go zoom, bow, instantaneously back to zero. It's going to take 2, 3, 4, 5 seconds, and then the needle's going to start to come back down to zero. So it's a really good indicator of what you're doing, but not until you're already doing it. You've got to be doing it for several seconds before it tells you what's going on. So on the inside of a vertical speed, if you were going to describe it, you'd say the vertical speed indicator gets its air pressure from the static system, just like the altimeter, and it has bellows, but these bellows, the air from the static pressure can go in and out and make them expand and contract. The pressure inside of the case, not inside the bellows, but inside the whole case, can escape or have air come in through a metered orifice. And it's the difference in the pressure between the bellows and inside the case that makes the needle go up and down. After you stop going up or going down, the air will go through that metered orifice and have and equalize the pressure between the inside of the case and the inside of the bellows, and the needle will come back to zero. And, of course, the needle lags by several seconds what's actually occurring. All right, already talked about the lag, and that's good enough. I don't care about that last sentence. So just for fun, don't write that down. We already covered the fact that there's a lag. All right, airspeed indicator. Oops, not too many. There's 5 different altitudes. There's 4 different airspeeds. The good news is that the indicated one is really, really easy. It's just like the altimeter. If you look at an altimeter, no matter how well you set the Kollsman window, whatever altitude it reads, that's the indicated altitude. Same thing with an airspeed indicator. No matter what, if you look at the indicator, that's your indicated airspeed. And here's the other good news. The vast majority of the time when you're flying that airplane, all you care about is the indicated airspeed. When you're trying to decide how fast do I have to go down the runway before I pull back on the stick or pull back on the control wheel to lift it up, that's called rotation speed. You look at the airspeed and you do it based on indicated airspeed. When you're climbing out and you want to clear obstacles, that's VX, that's best angle. You apply an indicated airspeed. If you want to climb as fast as you can, that's VY, best rate of climb. You don't have to write these numbers down at the moment. That's an indicated airspeed. If you want to know how slow do I have to go before I can laps down, it's an indicated airspeed. When will the aircraft stall? It's an indicated airspeed. How fast can I dive the airplane before the wings bend? That's an indicated airspeed. And guess what? There's no knob on the airspeed indicator. Yay! Yay. You know what? I think that's enough. Well, tell you what. You know what? I want to look at a picture just to start giving you an idea here. So here's a diagram of an airspeed indicator. I know we're going over time. We've got green and yellow and red. And pretty much generally, green is normal, and yellow is caution, and red is nuh-uh. I mean, what's that? No, because in this case, there's only one red, and that's at 100, just under 180, and that you'll never get that speed on the. You'll go off the end of the runway. So no. So green is normal. Yellow is caution. I'm sure you're writing this down. And red is never. I'll get to it in a second. Never exceed. And these color codes that I'm talking about here don't just apply to airspeed indicators. We're going to get to it at some point. They apply to the oil pressure gauge and the oil temperature gauge. Like how hot can the oil get? There's a red line. What's the best oil pressure? There's a green arc. In this case, you notice there is a green arc. It goes from, let's see, let's look at the green arc here. The green arc is starting right around here. Let's see if that's 40, 60, that's 50. If that's 50, that's 55. I'm going to say that that's 53. It's hard to read. I'm going to say that that's 53, and it goes all the way to right here, which is 120, 130, 125 to 130. I'm going to call this 128. So this green arc right here goes from 53 knots indicated airspeed all the way to 128 knots indicated airspeed. So that's saying that's the normal operation of the airplane. So the bottom of the green arc, in this case, 53 knots, there's something there. It's the stall of the airplane in a clean configuration. When I say clean, that means the flaps are retracted up into the wing. And if you have retractable landing gear, the landing gear is retracted up into the airplane. So that's what I mean by clean. The airplane has the least amount of drag. There's no drag from the landing gear. There's no drag from the flaps. That's what that is. If the airplane is at sea level and it's loaded to, actually it doesn't matter if it's at sea level, if it's loaded to gross takeoff weight, the heaviest you can legally fly the airplane, if you pitch the nose up with no power, with no throttle on, and you slowly pull the power back, that's where the plane will stall. So in a little tiny airplane, the landing gear doesn't go up and down. So if you're flying around the airport and the engine quits, and you don't put the flaps down, the gear is already in as clean as it's going to get in this airplane. You want to stay above 53 knots, unless you're right down on the runway. This white arc, you notice the white arc goes all the way down here to about, I'm just going to make up a number and say that's at 49. This white arc is the normal operation of the flaps. And the bottom end of it, it's 4 knots slower than the green arc. That's if you go to full flaps, where will the airplane stall then? And if you have retractable landing gear, that means the landing gear is also extended. So that's the airspeed that the airplane will stall if everything is hanging out and dirty and creating drag. Now the flaps are creating lift, which is why you can fly 4 miles an hour slower. So generally, if this was the airplane you were going to be flying around, if you didn't have any flaps in and you were going to be close to the airport and you're slowing down to come in and land, you're probably going to fly this airplane at around 70 knots. This 70 knots may be your normal speed, your normal slow. You don't have to write that down. There's no such thing as normal slow speed. And what I'm just trying to get at, the fact is, look at, you have a lot of airspeed before you're going to stall the airplane. And then if you go to full flaps, then you can probably fly around at 65 knots and look at how much you've got until the airplane stalls. So this is what's really nice, and I want to be really careful about it, and we're going to end today's lecture with that, is that part of what you're going to do as a pilot is to do things safe and do things with a margin of error. So you can screw up a little bit, everything is fine. So in this case, if you're flying at 65 knots and the flaps are all the way out and the landing gear is all the way out and the airplane's not going to stall till 49, that gives you 16 knots before you stall. If you get down to 60, you go, and you push the nose forward back to 65, but you were still 11 knots faster than you needed. And the good news is the airplanes you're going to be flying, unless they're really, really old, they have a stall warning indicator that makes noise at about, and they vary, but about 10 knots before you stall. So when you hear that noise, if you're not touching down on the ground, then you're going to go, and you're going to push the nose forward. The only time you want to hear that is on takeoff roll, it might chirp or come on just a little tiny bit just as you're taking off. But when you're coming in and land, you're not going to hear it until you're coming down to land, and you literally get down to about 30 or 40 feet above the ground. You've pulled the throttle all the way back. You level off at 30 or 40 feet, and the airplane starts to slow down. As it slows down, the wing gets less lift because you're going slow, so it starts settling to the ground, and you start pulling back on the wheel or the stick, and the nose comes up a little bit. And the hope is, then the horn comes on, and then just as you touch the ground, the wings stall. Right at that exact moment. It doesn't have to be at that exact moment, but that's what you're aiming for. So in this case, you would want to touch down at 49 knots, and you would have done it just perfect. So the last thing, I guess I'm not done with the last thing. The last thing I want you to think about today is if you had an engine failure, and you put the gear down and put all the flaps down, and you were landing somewhere out in the middle of the central San Joaquin Valley, you're going to touch the ground at 49 knots, which is 15% faster than that is miles per hour, so that's going to be like 55 miles an hour or something. Okay. The whole point of when you're landing on you and your passengers, not going 100 miles an hour when you get to the ground. And even jet airliners that go 500 and 600 miles an hour, they're touching down at around 100 or 110. But of course, they need a mile of runway. Okay, that's enough talking. Class is dismissed, and it's let's see, it's 13 after in real life, so 33 after in real life. 23 after. 20 no. I can't think. 15 and 3 is 18. 29 after. 29 after. 29 after in real life. 29 after.